All right, so let's talk about this for a second. It says that there is a lightweight beam that is supported on a fulcrum. I know it's unfair. I'm not only good at physics, but also an artiste. Okay, and it's 5 meters long, and the fulcrum is in the midpoint. There's a mass of 3 kilograms, right? There's a mass of 3 kilograms on the left end. And then there's a mass of 9 kilograms at the other end. So let's just start drawing that stuff in, okay? So on this side, I got a mass. That's 3 kilograms. On the other end, there is 9 kilograms. The third object, M, is place a distance D to the left of the fulcrum. So there's something here. What is the mass and distance? We'll pair this. So this is an interesting one because we have to calculate the sum of the masses. So we have this mass, we don't know what it is, we'll call it M3. And then it's a distance D from the fulcrum. And that's supposed to be an M and a 3 and a D, but you know how this is. So the first thing I need to do is I need to sum all of, and it's basically, it doesn't say it, but it's saying that the sum of all the tension, or not tension, the torque should equal 0 because it's in a state of equilibrium. Well, what would that be? Well, remember that the force coming down here, this force is equal to 5 times 9.8, right? And then we're also going to have, actually, I'm just going to write in G because I think the G's will cancel. So we'll say 5 times G is this force. And then the radius is, if it says it's 5 meters, let me just double check this. It says it's 5 meters long. So what would that distance be? Oh wait, let's also think. So this is going to go counterclockwise. So this is positive. This is counterclockwise. So that would be T2. And then this is clockwise. So that would be negative, right? You guys with me so far? Okay. So then this would be the force, which would be, remember that it's R F1 F1 plus R2 F2 minus R3 F3. Okay. So what's that? Well, this one is 2.5, right? 2.5, because that's the distance from here to here is 2.5 because it's 5 meters long total, times the force, which is going to be 5G. Plus, we don't know what R2 is, and we don't know. Actually, I got them backwards. We'll call this 2 and we'll call this 3. So I don't know what mass 2 is, but I know it's going to be multiplied by G minus R3, which is also 2.5. And then over here, I have 2.5 times 9G. Okay. And that has to equal 0. So if I take, and this all has to equal 0, right? So now if I take every term and divide it by G, the G cancels. That's good. And so I have 2.5 times 5. What's that? What's 2.5 times 5? Isn't it 12.5? So I have 12.5 plus the radius 2 times the mass 2, right? Minus 2.5 times 9. What's 2.5 times 9? 13.5? Double check.
Quick question. Why is force 1?
Oh, you're right. It's 4.5 plus 18, right? Yeah, so it's 22.5. Why is what?
Why is force 1 5G?
Because the mass is 5 kilograms.
It's 3.
Okay, so that changes it.
Yes.
So this should be 3. Good catch. So this should be this should be 3G. So this should be times 3G. So 2.5 times 3 then would be 7.5. Is that right?
Yeah.
Okay. All right. Now what is 7.5 minus 22.5? Is that negative 15? Okay, so we've got negative 15 plus R2 M2 and then if I add 15 to both sides, I've got 15 is equal to R2 M2, right? And so that means that the product of these has to multiply to equal 15. So then if you go back to the actual problem, unfortunately you have to multiply these numbers out. What was that, 28? Mm-hmm. Yeah. When you look at the answers, in other words, these numbers have to multiply to get to be 15, so it's going to be B, because 12 times 1.25 equals 15. Does that make sense? So 1.25 meters times 12 kilograms. That's the only combo that works. Did that help?
Yes.
Okay, good job.